In this video, we're going to analyze antiderivatives graphically. Let's take a look at this example. This example is important because you will see this type of questions on the AP exam a lot. It says the graph of a continuous function f, which is given over here. This is a graph of f with domain 0 to 8. Let h be the function defined by h of x equals the integral of f of t from 1 to x. So we have h of x equals integral of f of t from 1 to x. Now part A says find h of 1. So in order to find h of 1, that means x is equal to 1. So all we got to do is plug in 1 instead of x. So we integral from 1 to 1, f of t dt. Now what is that? You have the same lower and upper limit, so it will be 0. h of 1 is equal to 0. Now part B says, is h of 0 positive or negative? And it says justify your answer. Whatever they ask you to justify your answer, you have to give rationale for your answer. So B. What is h of 0? Well, h of 0 is the integral from 1 to 0 of f of t dt. Now take a look at this. You usually want to have a lower number on the lower limit. So if you change it, I'm going to change the 0 and 1. That means I have to take out the negative. Now what is the integral of f of t from 0 to 1? That is represented by this right here. And you know that this value over here is going to be positive because f is above the x-axis and this area is positive. But then you're multiplying positive by negative, so it will be negative. Therefore, h of 0 is negative. Now, part C says, find the value of x for which h of x is a maximum. So we got to find the maximum value of x that h of x is maximum. Now, what is h prime of x? When you take the derivative of h, you're just going to get f of x. So we could say that f is same thing as h prime. So let's get the chart. F, or we could call it h prime. Now, we're looking at from 0 to 8. What are the critical numbers? Critical number is at 1 and 4. That's when f or h prime is equal to 0. Now, f or h prime is positive from 0 to 1. And f or h prime is also positive from 1 to 4. And from 4 to 8, f or h prime is negative because the graph is below the x-axis. Now, you know that the maximum could occur at the endpoint, so h of 0 and h of 8. Also look at the sign of h prime and f. It's going from positive to negative, so maximum could also occur at h of 4. Now we got to find h of 0, h of 4, and h of 8. and see which one has the highest value. So what is h of 0? We found it earlier that h of 0 is some negative number. We don't know exactly what negative value it is, but it was a negative. What about h of 4? That will be integral from 1 to 4 of f of t dt. Now what is the integral of f of t from 1 to 4? That will be represented by this area right here. And since this area is above the x-axis, the integral will be positive. Now what about h of 8? That will be the integral from 1 to 8 of f of t dt. Integral from 1 to 8 of f will be this area and also plus this, the area below the x-axis. But notice, this area below the x-axis is greater than these two areas combined, which are above the x-axis. Therefore, the integral will end up being negative. Now, which one has the highest y value? Well, we only have one positive. Therefore, the maximum will occur when x, notice, we're looking for the value of x. So maximum value occurs when x equals 4. Now let's take a look at part D. It says find the value of x for which h of x is a minimum. Part D and part C are closely related. We're going to use the same analysis here. And the minimum, notice the h prime or f, the sign does not change from negative to positive in the interior of 0 to 8. So we know that it could only occur at the endpoint. So we could reject h of 4. We don't have to worry about h of 4 when we find the minimum. It could either happen at h of 0 or h of 8 at the endpoints. Now, which one has a lower y value, h of 0 or h of 8? Well, if you look at this, from 0 to 4, h is increasing. And from 4 to 8, h is decreasing. But notice, h decreases more than it increases because the area below the x-axis is greater than the areas that are above the x-axis. So if you graph, let's say you have a graph of h, you will look something like this. It's going to increase less than it decreases. So therefore, the absolute maximum will occur at the right endpoint, not the left endpoint. So we know that the minimum occurs when x equals 8. And this was a sketch of h. Now let's look at part E. Find the x-coordinates of all points of inflection of the graph of y equals h of x. Well, if you want to find the inflection points of h, we need to look at h double prime. And we know that h prime of x is same thing as f of x. Therefore, h double prime of x is same thing as f prime of x. And we could get f prime of x from the graph of f, which is same thing as h prime. So let's draw this line. So h double prime or f prime. Now you're going from 0 to 8. Now, this is f. So when f is decreasing, that means f prime is negative, which is same thing as h double prime. So from 0 to 1, H double prime or F prime is negative because F is decreasing. And then from 1 to 3, F is increasing. Therefore, F prime should be positive. And from 3 to 6, F is decreasing. Therefore, F prime is negative. And from 6 to 8, F is increasing. Therefore, F prime is positive. So where are the X values, X coordinates for all the inflection points for H? Well, that's when the sign changes, either from negative to positive or positive to negative. It happens when X equals 1, X equals 3, and X equals 6.